The myth of size. We have always feared the wrong things. The lion, the shark, the towering predator with claws and teeth. These are the creatures that haunt our stories. The monsters we imagine when we think of danger. But nature operates on a different logic. The most dangerous animals on Earth do not roar. They do not chase. Many of them, you will never see at all. They drift in warm waters, light as silk. They burrow into soil, thinner than thread. They ride the wind on wings too small to notice. And yet, they kill more humans every year than all apex predators combined. This is not a flaw in nature's design. It is the design. Invisibility is not weakness. It is a weapon. To understand why, we must abandon our assumptions about power, about size, about what it means to be deadly. Because the animal kingdom has spent millions of years perfecting a single truth. The predator you cannot see is the predator you cannot escape. Consider the box jellyfish. A creature so transparent it dissolves into the ocean around it. Its body is over 95% water. Its tentacles trail behind like threads of glass. And yet, within those tentacles lies one of the most potent venoms on Earth. A single sting can stop a human heart in under 5 minutes. There is no warning, no shape emerging from the depths, only a brush of something invisible, and then fire spreading through the bloodstream. The box jellyfish does not hunt with speed or strength. It hunts with absence. This is the paradox we will explore. Why has evolution favored the invisible? Why do the smallest creatures carry the deadliest weapons? And what does this reveal about the nature of survival itself? We will descend into oceans where transparent killers drift in silence. We will walk through jungles where the deadliest animals fit on a fingernail. We will trace the paths of microscopic organisms that have shaped human history more than any war. Because the story of danger is not written in fangs and claws. It is written in camouflage, in venom, in smallness. The creatures we will meet are not hiding because they are weak. They are hiding because they do not need to be seen. Their power lies precisely in their invisibility. And by the time you notice them, it is already too late. This is the hidden world of the invisible killers. The animals that evolution made small, silent, and spectacularly lethal. The ones that prove, beyond all doubt, that in nature, the deadliest things are the ones you never see coming. Venom in miniature. The blue-ringed octopus is smaller than a golf ball. It rests in shallow tide pools along the coasts of Australia and the Pacific. Its skin is soft. Its movements are slow. To the untrained eye, it looks harmless, almost decorative. And then it bites. There is no pain at first. The bite is too small to feel. But within minutes, the venom begins its work. Tetrodotoxin, a neurotoxin so powerful that a single octopus carries enough to kill 26 adult humans. The muscles stop responding. The lungs forget how to breathe. The victim remains fully conscious as their body shuts down around them. There is no antivenom. The blue-ringed octopus does not need size to dominate. It has replaced mass with chemistry. This is the economics of venom, a strategy that allows the smallest creatures to punch impossibly above their weight. Consider the cone snail, a creature that moves so slowly it seems almost inanimate. Its shell is beautiful. Collectors prize them. But inside that shell is a harpoon, a hollow tooth that fires forward like a needle, injecting venom with over 100 different compounds. Each cone snail species has its own unique cocktail, fine-tuned by millions of years of evolution. Some compounds paralyze prey instantly. Others block pain signals, so the victim does not even struggle. Some are now being studied for human medicine, potential treatments for chronic pain, epilepsy, even heart conditions. The cone snail is a pharmacy and an assassin, wrapped in a shell no larger than your thumb. This is what evolution discovered long before we understood chemistry. Venom is efficient. It allows a creature with no claws, no teeth, no speed, to take down prey many times its size. 1 microgram in the right place can do what brute strength never could. And crucially, venom does not require visibility. The deathstalker scorpion hides in desert sands, its pale body nearly invisible against the rock and dust. It emerges only at night, moving in silence. Its sting delivers a neurotoxin that causes fever, convulsions, paralysis, and sometimes death. Most victims never see it before they feel it. The Brazilian wandering spider hides in banana shipments, in clothing left on floors, in dark corners of homes. Its venom is one of the most potent of any spider. It does not build webs. It wanders. And that wandering brings it into contact with humans more than almost any other deadly spider on Earth. The pattern emerges. Invisible, venomous, lethal. These creatures did not evolve to be noticed. They evolved to be effective, and they are terrifyingly good at their jobs. The camouflage killers. The stonefish does not move. It lies motionless on the ocean floor, its body encrusted with algae, its skin textured like rock. To every sense, it is indistinguishable from the reef around it. You could swim directly over it and never know. You could step on it, and that would be the last step you ever took without pain. 13 spines run along the stonefish's back. Each one is a hypodermic needle connected to a venom gland. The pain is described as the worst a human can experience. Victims have begged for the affected limb to be amputated. Some have died from shock before the venom itself could kill them. The stonefish did not evolve this defense for humans. It evolved it because invisibility alone was not enough. It needed a deterrent so severe that nothing would ever make the mistake of touching it twice. Camouflage is one of nature's oldest strategies, but in the hands of venomous creatures, it becomes something more sinister. It becomes ambush. The Gaboan viper of the African rainforest possesses the longest fangs of any snake, up to 2 inches. Its venom yield is enormous. A single bite can deliver enough toxin to kill multiple adults. But what makes it truly dangerous is its patience. The Gaboan viper's skin is a masterpiece of disruptive coloration. Browns, tans, purples, arranged in geometric patterns that break up its outline completely. It lies among leaf litter, indistinguishable from the forest floor. It does not hunt. It waits. Animals walk directly over it. And when one steps too close, the strike comes faster than the human eye can process. This is the mathematics of ambush predation. Energy is expensive. Moving takes effort. Visibility invites competition and danger. But stillness, combined with perfect concealment, turns the environment itself into a trap. The predator does not chase prey. It lets prey come to it. In the shallow waters of the Indo-Pacific, the reef stonefish sits beside its cousin the scorpionfish. Both are masters of disguise. Both are covered in fleshy appendages that mimic coral, sponge, and algae. And both carry enough venom to ruin a human life. Divers learn to recognize them, but recognition requires knowing what to look for. The untrained eye sees only rock. This is the genius of camouflage killers. They remove themselves from perception entirely. You cannot fear what you cannot detect. You cannot avoid what you do not see. And in those tropical waters, in those rainforest floors, in those desert sands, they wait. Invisible, patient, lethal. They have been perfecting this strategy for 100 million years. The weight of small numbers. The mosquito weighs approximately 2 milligrams. You could hold 1,000 of them in the palm of your hand and barely feel the weight. And yet, this creature, this fragile, whining insect, has killed more humans than any other animal in history. The numbers are almost incomprehensible. Malaria alone kills over 500,000 people every year, mostly children, mostly in sub-Saharan Africa. Add dengue fever, yellow fever, Zika, chikungunya, West Nile virus. The mosquito is not venomous. It carries something worse: passengers, parasites, viruses, organisms that use the mosquito's invisibility to travel from host to host, replicating, spreading, killing. This is the danger of small things. They exist beneath our threshold of concern. We swat them away, barely registering their presence. But in that moment of contact, that fraction of a second when the proboscis pierces skin, a transfer occurs. Pathogens enter the bloodstream. Parasites begin their life cycle inside a new host. And by the time symptoms appear, days or weeks later, the mosquito is long gone. Invisible transmission. Invisible infection. The tick operates on similar principles. A creature so small it can feed for days without detection. It burrows into skin, secreting analgesic compounds that numb the bite site. The host feels nothing. Meanwhile, the tick's saliva delivers bacteria. Lyme disease, Rocky Mountain spotted fever, tick-borne encephalitis. The symptoms are delayed. The connection to a tiny bite often goes unrecognized. This is what makes these creatures so dangerous. Not venom, not violence. Stealth. The tsetse fly haunts the forests and savannas of Africa. Its bite delivers trypanosoma parasites, the cause of sleeping sickness. Without treatment, the disease is fatal. The parasites cross into the brain, disrupting sleep cycles, causing confusion, and eventually death. The sandfly, barely visible to the naked eye, transmits leishmaniasis, a disease that affects millions, disfiguring and killing. The kissing bug of Central and South America feeds on human blood at night, biting near the lips. Its feces carry Trypanosoma cruzi, causing Chagas disease, a slow killer that damages the heart over decades. These creatures do not need to be powerful. They need only to be numerous and invisible. And they are everywhere. In the air we breathe, in the grass we walk through, in the beds where we sleep. The weight of small numbers is this: 1 million invisible encounters, each one carrying the potential for catastrophe. And against such enemies, claws and teeth mean nothing. The invisible arms race. Evolution does not stand still. For every defense, there is an adaptation. For every toxin, a resistance. For every camouflage, a sharper eye. The history of invisibility is a history of escalation. Consider the rough-skinned newt of the Pacific Northwest. Its skin contains tetrodotoxin, the same compound found in the blue-ringed octopus, the pufferfish, and certain dart frogs. Enough toxin to kill almost anything that tries to eat it. But the common garter snake has evolved resistance. Through a series of genetic mutations, these snakes can consume rough-skinned newts and survive. Their sodium channels, the target of tetrodotoxin, have changed shape just enough to reduce the toxin's binding. The newts responded by becoming more toxic. The snakes responded by becoming more resistant. This molecular arms race has been escalating for millions of years. In the oceans, a similar battle unfolds. Nudibranch, soft-bodied sea slugs, have no shells, no spines, no obvious protection. They should be easy prey. But many nudibranch feed on hydroids and anemones, stealing the stinging cells of their prey and incorporating them into their own tissues. They become armed with borrowed weapons. Other nudibranchs synthesize their own toxins, advertising their danger with brilliant colors. They have abandoned invisibility for the opposite strategy, unmistakable visibility that warns predators to stay away. This is the paradox. Some creatures survive by being unseen. Others survive by being impossible to miss. Both strategies work. Both have been refined over millions of years. Humans have entered this arms race. We develop antivenoms. We engineer insecticides. We create vaccines against mosquito-borne diseases. But the invisible killers adapt. Mosquitoes evolve resistance to DDT, then pyrethroids, then organophosphates. Parasites develop immunity to chloroquine, once our most powerful anti-malarial. Bacteria, the most invisible killers of all, evolve resistance to antibiotics faster than we can develop new ones. This is the nature of the invisible arms race. There are no final victories, only temporary advantages. Each innovation we create is met, eventually, by an adaptation. Each weapon we deploy selects for resistance. And the creatures we fight have one advantage we cannot match: time. They reproduce in days. We develop drugs in decades. They mutate in thousands of generations while we struggle through one. The invisible killers are not static threats. They are evolving, adapting, changing, always one step ahead, always finding new ways to remain unseen. And the arms race continues. The lesson of invisibility. What does it mean that the most dangerous animals are nearly invisible? Perhaps it means we have misunderstood danger entirely. We evolved on African savannas, surrounded by large predators. Lions, hyenas, crocodiles. Our fear responses are calibrated for size, for movement, for the obvious threat. But the creatures that have killed the most humans, across all of history, are the ones that bypass those ancient alarms entirely. They are too small to trigger fear, too silent to notice, too simple to seem threatening, and so they slip past our defenses. The mosquito in the night, the tick in the grass, the bacterium in the water. There is a lesson here about the nature of power. Strength is not size. Danger is not spectacle. The most effective strategies in nature are often the subtlest. Camouflage, venom, symbiosis with parasites, reproduction in enormous numbers. These are not the strategies of weakness. They are the strategies of optimization. Evolution does not reward the dramatic. It rewards the successful. And invisibility is spectacularly successful. We are surrounded by creatures we cannot see. Bacteria cover every surface. Viruses drift in every breath. Parasites wade in soil, water, and blood. Most of them are harmless. Many are essential, but among them are killers, refined by billions of years of evolution to exploit every gap in every defense. They do not hate us. They do not target us. We are simply part of their environment. The deep-sea anglerfish lures prey with light in total darkness. The trapdoor spider waits beneath the soil. The parasitic wasp injects eggs into living caterpillars. These creatures operate in dimensions we barely perceive. And the more we study them, the more we realize how little we have seen. There are viruses in the ocean that have never been cataloged. Parasites in rainforests that have never been named. Venoms that have never been analyzed. The invisible world is vast beyond imagination. And it is filled with danger we have only begun to understand. Perhaps the greatest threat is not any single creature. Perhaps it is our own certainty that we see clearly, that we know what to fear, that the dangers worth worrying about are the ones we can already perceive. The most dangerous animals are nearly invisible, and they always have been.